Hello lads. So here's a more difficult one. So we're going to prove the sum of n, where n is equal to 1, of 1 over n plus 3 times 1 over n plus 4 is equal to, let's see, n over 4 on n plus 4. Okay, so what would this look like in the real world? Well, let's do our steps. Step 1, let's prove it for n equals 1. So 1 over 1 plus 3 times 1 plus 4 is equal to 1 over 4 on 1 plus 4. So let's do that. That's 1 over 1 plus 3, so that's 4 plus 5. 1 over 20 is equal to 1 over 20. So it's true for n equals 1. Okay, let's assume it's true. Let's assume it's true for n equals k. So that would be 1 over k plus 3, and k plus 4 is equal to k over 4 on k plus 4. So we're going to assume it's true for n equals k. Okay, and then step 3, we're going to prove it's true for n equal to k plus 1. So that's 1 over k plus 1 plus 3 times k plus 1 plus 4 is equal to k plus 1 over 4 on k plus 1 plus 4. Right, so let's tidy this up before we prove it. Okay, so that's 1 over, what's that, k plus 4 and k plus 5 equal to k plus 1 over 4 on k plus 5. Now, you're thinking to yourself, well, how am I going to prove that? Well, remember, this sequence, the k plus 1 sequence, has, well, you could start with 1 over, what is that? 1 over, let's see, k, 1 over 20 plus 1 over, what did we work this one out? K plus 3 by k plus 4 plus k plus 1. So there is your step 2 plus your step 3. Gives you this. So all I have to do is add this to step 2. Okay, so there's my step 2. I'm going to add that to that, and it should be that. And if that's true, then that must be true because I added the next, all I added was 1 to it. Okay, plus 1. So if that's true, that's true. And if that's true, then we know this is true. So that must mean add plus 1 to that must be true. So there's your circular argument done. So let's get a common denominator here on this side. 4k plus 4k plus 5. So that into that goes k on k plus 5, and that into that goes 4 times 1. And that should be equal to k plus 1 over k times k plus 5. Doesn't look like it, but let's see what we can do. Let's multiply out the top line. We get k squared plus 5k plus 4 over 4 on k plus 4 by k plus 5. Okay, now that looks solvable. Let's see. That's k, a 4 and a 1, and a plus and a plus. And suddenly, there's something I can see here. They cancel. There's a multiplication top and bottom, so I can divide out k plus 4 from the top and the bottom. So that leaves you with k plus 1 over 4 on k plus 5, and that's equal to k plus 1 over 4 on k plus 5. So, how do we do? How do we finish this up? We just say it's true for k n equals k plus 1. Therefore, it's true for n equals k. And we have shown it's true for n is equal to 1. Therefore, it's true for n equal to 2 or 3, etc. So there you have another proof done. Okay.